Hello everybody and welcome to the homework helper for statistics 6. Okay, the first thing that we're going to be doing in the ready section is a little bit of a review about the probabilities that come out of a two-way table. So I'll go over a couple of those things as a quick little refresher and let you go from there. The first thing that we need to look at is we have our two-way table, we have boys and girls, cats and dogs, totals and totals. Remember that these on our edge, these totals, these are called our marginal frequencies, and the things in the middle are called our joint frequencies. So marginal, and joint frequencies. Now let's give a little bit of a look at what's being asked of us. 1, 2, 3, and 4 are all asking about the probability of a single category. So every time we're thinking about the probability of a single category, we look at whatever category we're looking at and then take that out of our total. Okay, so for example, P of B, we're going to assume B is boys. And how many boys do we have? We have a total of 100. So the probability would be 100 out of 152, and then we can reduce that fraction accordingly. G would be 52 out of 152, reduce the fraction accordingly. So this isn't the complete answer. I am expecting you to reduce that fraction, but for the sake of brevity, I'm going to assume that you can do that no problem. Where we get into a little bit more complicated is when we have these sorts of symbols where we're looking at different slices. When we have P, C of G, right, like so, we're looking only at our girls to start this off. So we are only, what the thing behind the line is, or you can think of it as like the denominator even, what that is telling us is that is going to be our focus. So we're only looking at girls. So I already know that my denominator is going to be however many girls we have, which is 52. And then I'm seeing if we're looking at girls, what's the probability that they like cats? And we see that that's going to be a 41 out of 52. Okay. C or B, this is an inclusive or. So if we were to pick out of the total, what is the chance that a person likes cats or is a boy? So this one gets a little bit more complicated. If we're thinking about cats or a boy, again, this time we're still looking at the total for an or, so that's still going to be 152. But how many like cats? Well, we've got 73 that like cats, okay? So we got 73. How many are boys? 100. But because we looked at all the cats and we looked at all the boys, we double counted the boys who like cats. So we have to do 73 plus 100, but we need to subtract that 32. 73 plus 100 minus 32 over 152 is going to be our probability. This is the same as number 5, but this is an and statement. What is the probability of boys and dogs? So that it's a boy who likes a dog. So it would just be this population here that is our boys and dogs population. So that's going to be our 68 out of 152. Okay, and then the rest of the questions are going to talk about the different sampling sizes. Okay, let's go ahead and go to the set piece. It wants us to distinguish between surveys, observational studies, and experiments. This is what we did in class on this topic. So essentially what you need to do is you need to look for what's going on in each scenario. So if we're to determine if a new pain medication is effective, we randomly assign 2 groups of people to use pain medication in group 1 and a placebo in group 2. The word placebo is a very clear sign that it's going to be an experiment. Anytime there's a control group, right? Anytime there's a control group, it's going to be an experiment. Okay, let's go ahead and flip over, look at one more. Let's get this on the screen correctly. Officials wanted to determine if raising the speed limit from 75 to 80 would have an impact. They determined they watch a stretch of highway when the speed limit is 75 and see how many accidents are there. They observe the number of accidents over a period of time on the same stretch of highway for a speed limit of 80. We even see the word here, observe. They're looking at one thing, they're looking at another, they're comparing those results. That's going to be observational. Easy enough from there. I'm not going to do too many of these. I think this one isn't that bad. Let's go ahead and go to the go section where we're recalling normal curves. This is a bit of a review, so let's do it one more time. So the average resting heart rate of a young adult is approximately 7 beats per minute with a standard deviation of 10 beats per minute. Assuming resting heart rates follows a normal distribution answer the following question. So we know we've got a normal distribution here, and it wants us to draw and label the normal curve that describes this distribution. It wants us to label the mean, which is our mu, and the measurements 1, 2, and 3 standard deviations, that's our sigma, out of the mean. Sweet, I know how to do this. So if our mean is 70, 1 standard deviation away is 10, so this is going to be 80, that's 1 standard deviation, 90, that's 2 standard deviations, 100 is 3 standard deviations. Now it also goes the other way, okay? So I got to go back to 60, I got to go back 2 standard deviations to 50, and I've got to go back 3 standard deviations to 40. And now I know the top of my bell curve is going to be at 70. My inflection point is going to be at 60, and remember when we're doing the inflection point, that's kind of like, it kind of curves, and then the inflection point is where it starts to flare out. The inflection point where it starts to flare out. So that would be, oh, looks like I froze. Let me refresh this. Boop, and boop, boom, there it is. It starts to flare out, starts to flare out. So that becomes our curve. Okay, it then is asking what percent of people have a heart rate between 55 and 80. So we're trying to figure out the percentage difference from 80 beats and 55 beats. Now the issue with this is 80 is one of our standard deviations, but 55 is in between our standard deviation. So we have to figure out how far percentage-wise this is. Because this is on our standard deviation, we could look at our chart, figure out, you know, exactly how much that is, yada, yada, yada. You know, where is it? It's in this packet somewhere, I'm sure. Right? We could look here, be able to figure out exactly, you know, where we're at +1 standard deviation at 80. So I know it's going to be this, plus this, plus this, plus this, plus this, plus this. But I don't know where 55 is. Actually, this one I kind of gave it to you. I told you that that's going to be at -1.5 standard deviations. But assuming that we didn't have that, we'd have to be able to use our z-scores. So easy enough, I need to find the z-score of my low value here. And to find the z-score, I take whatever my value is, I take my n, I subtract my mean, and I divide by my standard deviation. So for my low, for here, that's going to be 55 minus my mean, 70, over my standard deviation, which is 10. So that's going to give me, what is that? That's going to give me a -15 over 10, which is a -1.5. So that's what my z-score is. Okay, this is my z-score for my low. And so now that I know my z-score for my low, I need to figure out what my percentage is at -1.5. We can refer to the chart. -1.5 is above 6.68%. So that's 6.68%. I then need to find my standard deviation for my high. That's going to be 80 minus 70, 80 minus 70 over 10, which is 10 over 10, which is 1 standard deviation. I need to figure out how many am I at 1 standard deviation. 84.13. 84.13%. And so now I know that the percentage in the middle is going to be these numbers here. It's going to be 84.13 as my high, and then I'm going to subtract 6.68 as my low. Let's crunch this out. So 84.13 minus 6.68, 77.45% of the people are going to be in that purple shaded region. 77.45% are going to be between -1.5 standard deviations and 1 standard deviation. Okay, so make sure you know how to do all of that. And again, here we use the chart to figure this all out, but also on the inside of this cover, I did give you a half standard deviation chart to look at as well. But that should do it. Good luck on all this, and see you next time.